Start another one. So here we are, 152, and today is disk imaging, the original stuff. This was the original computer forensics. Back in the early days, this was all you would do for computer forensics is just duplicate a hard drive. So let me bring up the slides. All right. Okay, so you can simply duplicate some files. You can just copy files to a removable device. That's one way to make a backup, and that can be when you gather data. It's not like there's just one way to gather data and the others don't count, because remember, in court, the evidence is the human testifying. It is not the technical thing you did. It is the human saying, I went and copied the data and I examined it and here's what it said. It rests on the credibility of the human. The particular technical technique you use does not matter as long as you have a forensic expert who can explain in court and convince people that the technical method was good enough, and as long as the opposing forensic expert cannot find something wrong with it. So any technique that is good that you can defend is all right. But what you typically go for is the best one, which is complete forensic duplication, where you copy every bit off the source. That is the standard that you would use, unless you have some reason why you can't do that. That would be your default activity, because then nobody can claim that you didn't get all the data. You made sure you got every bit. So that's all. And then you can recover deleted files sometimes, and you can make a perfect copy of that and give it to the other side, and then the both of you have complete records of the data for your the prosecution forensic examiner and the defense forensic examiner to examine. And they both have exactly the same data, so it's a very fair and defensible form of discovery when you go to court. All right, so you need a tool that can do that can take every bit of data off the storage medium, and it makes some forensic duplicate. If there is a read error on the medium, it has to handle that in some good way. Instead of just stopping when it finds a read error, you would have to keep going and record the rest of it and somehow make a log or a message telling you that there was a read error. So you don't want to make any changes in the storage medium while you're copying it. You want to make repeatable, verifiable results and logs that record everything that happened. And then, of course, nothing is ever very pure. When we say it copies every bit off the storage medium, that is not really true. It's usually all you copy is all the data that is available to the user. But there's data stored on hard drives that is never intended to be used by the user. It is the data that contains the firmware to run the hard drive itself. And if you get into hard drive hacking, this is what you mess with. You can mess with the firmware so the hard drive changes how it records data and reads data off the disk. And that's a kind of fun thing to do, and then you can hide data in unexpected places and stuff like that. But that's called the host protected area. But normally people don't do that. And there was a concern maybe 20 years ago. Some people said, you could in principle put data in the host protected area, like kiddie porn pictures, and then you would only be able to get it with special software, and nobody would ever find it when you did a forensic image. So ProDiscover actually added the ability to copy the host protected area. It was the only forensic tool that had that ability, but as far as anybody can tell, it never turned out to matter. There were no real cases where anybody actually put anything important in the host protected area. And so people just sort of lost interest in doing that. And it's not commonly done. All right. So once you get a forensic image, if you have like a 500 gig hard drive, you now have 500 gigs of data. So, or if you do, copy the complete disk, or you can copy just one partition, like C or D or E on a Windows machine, or you can make a logical capture of just certain folders and files. So here's the way the disk is. You have a whole disk here. You have a boot sector, which is 512 bytes right at the start. Then you have a partition here. The original equipment manufacturer can store things here. Then you have a partition table someplace here in the boot sector. And so you have partition 1, this is to say like the C drive, and then partition 2, this might be the D or the E drive. And that's the sort of thing that you have your disk partitioned into a couple of drives. And that's the way it would look. So if you copy the complete disk image, you just copy all of this. Every partition and all these control structures, like the boot sector and what's labeled OEM partition here, just every bit on the drive, which is, of course, the most complete, simple thing to do. And you can do that right in HXD. In HXD, you can open a raw disk, and if you do, you'll see a bunch of zeros at the start, and then NTFS starting here. There's stuff before these zeros, This is at 10 or 100,000 in hex. That's where the first partition starts on this machine. Before that is a copy of the MFT and all kinds of stuff. And you can also open just drive C, and that just starts at that NTFS mark. So that's what you see here. You can just open a raw disk right in HXD and view it. It's a raw disk editor in addition to a raw memory editor. And as I probably mentioned before, when computer forensics started maybe 25 years ago, this was the only tool we had was Norton Disk Editor, which was essentially HXD. It was just a raw hex editor to look at what was on the disk. And that was your forensic tool, and you could just read strings and stuff on the disk. And you can do it that way, but of course all the tools we have for modern forensics just are conveniences to make it easier to reassemble all the files from these raw disk images and search through them and such. All right. So you can use FTK Imager, for example. You can copy the whole drive or a logical selection or contents of a folder. So a physical drive is what copies the whole drive, and then when you're done, you have all the data. You can put it in various formats, like DD, SMART, E01, and AFF. These are just file formats to store it in. So if there's deleted files, or reinstalling the operating system, or reformatting the drive, all those things cause the old files to be no longer represented in the master file table, so they no longer have owners or file names or timestamps, but the data is still there. Until you actually write over the clusters storing the data, the contents of the files are still there, so that these activities create a whole bunch of deleted files that can be reconstructed to some extent. Some of them are damaged and can't be reconstructed, but some of them can be reconstructed, and in practice, a lot of them can be reconstructed, like half or more of them. All right, so the host protected area and device configuration overlay are these parts of the disk that are never used to store any user files under normal conditions. And so, like I say, that you could in principle hide malware there or anything you want, but it's not common. And there are no forensic tools I'm aware of in common use anymore that bother to copy them. You could do it, but it would be pretty painful to do. The procedure would vary on the brand and firmware on the hard drive, I think. You pretty much have to hack the hard drive firmware, which hobbyists do, but it just doesn't turn out to be worth the bother for most investigations. So active data is data in use, data that has a file name, it has an owner and creation date, it's in the directory. You could go into Windows Explorer and find your way to it. Unallocated space is the stuff that was deleted, so it's clusters that contain the contents of files, but they no longer are in the file table. They no longer have a file name or live in a whole folder or anything. And then there's file slack. Everything in the disk is stored in 512-byte clusters, or maybe larger, 2048 cluster. But the point is there's a little bit of data stuck at the end of your cluster. So you might have a file that is 8,000 bytes long that fills two 96-byte clusters, and then you store something that's 5,000 bytes long. So 3,000 bytes of the old file are hanging out at the end of the cluster. That's called file slack. These are by definition fragments of a file that you can never reconstruct a whole file, but you might be able to see part of a picture, part of a Word document or something there. In general, your most important data is the active data. These are the files in use. That's where the stuff that's actually in use is. And the second most important stuff is the unallocated space, where you can often reconstruct images and office documents and stuff that have been deleted. And often they were deleted because they're incriminating, so that can be important. This file slack is very unimportant. It's very unlikely that you'll find anything good in there. You'll never be able to reconstruct a whole image or anything, but in principle, there might be something there. All right, so you could image a partition if you wanted to, like just the C drive or just the D drive. Normally you don't bother with this. You just do the whole drive, but you could, in principle, if somehow you only have a search warrant that allows you to image one partition, which is not common because what a search warrant usually says is you can access files used by this person, but not files used by some other person or something, and that's not usually mapped geometrically onto the drive. But anyway, if you were to image a partition, then you could reconstruct deleted files on that partition, but not on the other partitions. All right. A logical image is quite common these days, and this is what all of our live acquisitions are doing. Although I guess in principle, you could do a forensic image with live acquisition by putting forensic software on the machine, but in general, mostly you're doing logical image. This is where you're just accessing files that are in the directory and copying them. This is also what normal backups do. You normally don't want to back up the deleted files, you back up the active files. All right. So if you decide to do a logical image, something other than a full forensic image, then of course record in your journal what you did and why you did it, because that is a question that might very well come up later. Why didn't you capture a full forensic image? There is an argument that perhaps you missed some evidence, so you ought to have an answer why you didn't do that for later. All right. So, for example, if you're on some kind of shared device like network attached storage, like Dropbox or something, you have thousands of users all using the same physical hard drive, your court order might let you seize somebody's data, but you can't seize everybody else's data. You don't have the authority. So that's when you would get just a logical image. You can only get the objects that are currently in use, that have an owner, and you can tell who the owner is, and the owner is the right person you're supposed to be investigating. The deleted files no longer have an owner, so you can't tell whether you're authorized to take them or not, so you can't take them. All right, that's the kind of thing. All right, so in this case, save everything you can, creation times, permissions, etc., and then save a hash of the stuff, so if you make a copy of it, you can verify the copy. And these, all the software that does normal forensic images can, of course, do logical images too. Logical images are really not much of anything. You could just, select them and drag them into a folder in Windows Explorer. That's all you're doing. All your software is sort of automating that process. And then there's all kinds of non-standard data. Weird things happen, like somebody hands you a USB stick, you have virtual machines. I've heard cases where the police had a phone and they didn't have any ability to digitally copy the data on the phone, so they just paged through the text messages and just took pictures. And then that series of pictures is evidence. It's not like mathematically perfect. It's not 100% of the evidence that was on the phone, but remember, the human is the evidence. He can say, these messages were on that phone, here's my picture, and that's evidence. That's like I looked out the window and I saw something happen. It doesn't mean I have perfect knowledge of exactly everything that happened, but I did see something, and that's now evidence in court. These pictures, these things were on that phone. Your forensic examiner would usually try to do a more thorough job than that, but if that's all you can do, that's something. That's why the main message in all this is, whatever you do, document it, because there will be questions later of whether you did the right thing, and you need to have a documentation of exactly what you did and why you did it. And even if you make a mistake or do something wrong, document it, because nobody's perfect. But if you don't even know what you did, then you'll really look incompetent, like a fool. You should at least be able to say, here's what I did. All right. So after you get some digital data, you should store a hash with it so that people can tell it hasn't been altered. And sometimes, if you have drives with bad sectors, then the bad sectors give you random data, and that will cause the hash to change every time. So then you cannot really have a second image of the same device and get the same hash. Would logical imaging be used for cloud resources? Yes, exactly. Where multiple users may use, that's exactly the point, yes. And that's extremely common these days, right? If you have a network share and everybody has their own folder on the share, different users are storing data, and you're only authorized to investigate one user, then you would do a logical image. That's exactly the case, because the deleted files that you were trying to recover with full disk images, you cannot prove that they belong to the person you're investigating, and so you're not allowed to get them. That's the most obvious logical reason to do it. Now, of course, in the world of incident response like we're doing, we don't anticipate going to court that often. We're mostly just trying to solve an attack in progress, and so we just use whatever's fast and easy. Let's see, I got more questions here. If two entities hash images of the same drive done by the same forensic software, yes. Mobo, that's the point. If you did a second image from the same drive and you have no write errors on the drive, no read errors, and you have a good write blocker, then those should be exactly the same and have the same hash. That is the standard condition that you would like. That's the classic kind of perfect forensic evidence. A forensic image of a drive that could be repeated exactly. Then you've got the perfect image and nobody can argue that there's anything wrong with it. In practice, often, you can't get that. But that's the gold standard. If you could have that, there would be like no argument that you got all the data. Sounded like cloud case. Yeah, good. Yeah, everything is going cloud. That's why I say this old forensic image of a single hard drive stuff is kind of becoming obsolete now that everybody's using cloud resources and shared resources and stuff. That was That was the way it was like 20 years ago when everybody had a big square computer on their desktop and everything was really stored on that one hard drive by one user. Nowadays, you end up with a lot of these complicated situations where it's not as simple as this hard drive is used by exactly one person and everything on there and it's theirs. Anyway, when you store one of these images, there's Access Data's native format is this advanced forensic format, but the standard that most everybody uses is in-case, which is actually not an in-case format. It's used by an old product called Expert Witness that's not used anymore. They made the format, but it makes these E01 and E02 files. This is what most people use. The main point of it is it's compressed, so it's easier to handle and copy. It's broken up into small files, so you can copy it onto things that are FAT formatted, so they can only have like 2 or 4 gigabyte maximum file size, and it has metadata attached to it, like hash values and the time it was collected and the name of the examiner and all that. So it's a nice, efficient, convenient format and commonly used. DD is what you get by the Linux utility DD, Disk Duplicator. It just copies bit by bit. So if you copy a 500 gig drive, you get a 500 gig file, which you have to store on a file system that can handle that. You'd have to have a drive larger enough to do it, like a 1 terabyte drive, and it would have to be formatted ext4 or NTFS or something that can actually have a 500 gig file. And then if you try to copy it on some removable device that's formatted FAT32, you can't do it because that can't handle a file that big. So this is pretty inconvenient, and it's not compressed, and it doesn't have any place to put the extra data like hash values and the time you examined it and stuff. That would be in a separate text file. So, this is the open source people tend to use. Most professionals pay for the Windows tools and they use E01, which is just a more handy way. But of course, they are all exactly the same. They're all exactly the same bits copied off of there. The only difference is whether you zipped it in a reversible way, so you can unzip it, and whether you broke it up into little chunks and added some extra data to record the name of the examiner and the hash and stuff. But all these formats contain exactly the same data, and you can convert one to the other. All right. So you should have hashes. You should have chain of custody. Who seized it and when you seized it, and other documents. The serial number of the machine and other things you might have. You should have records, so that when somebody comes up like 2 years later and you have left the company and they have to go to court, they can look at this, and figure out what's happening. Anyway, that's the game here. So open source tools, typically like DD files, almost all the commercial tools expect those E01 files in Expert Witness format because it's the most handy, and there are some others like AFF that are occasionally used, but typically it's one of these two. All right, and by the way, if you were going to make a complete forensic image of a multi-disk array, like a RAID, this can be done, but it's very difficult. Then you just better make DD files, get the whole thing, and then you're going to have to somehow reverse the flipping from platter to platter. There was a CTF like that I did one time, where you had forensic images of a RAID, and you had to reconstruct things from 64 kilobyte blocks in a certain pattern. It was actually pretty interesting. You can do it. And that's what you have to do for SSD drives. If you want to get a complete forensic image of an SSD drive, the most difficult, most complicated solution is called chip-off forensics. You take apart the drive, you remove the memory chips, and you suck the data off them one by one. And then each bit is on a different chip. And you have to reassemble the bits from all these images in some complicated pattern to reconstruct it. They can do it at drive savers, but of course that's expensive, and normally you don't need to do all that. But I mean, if you've got an SSD drive with your precious pictures or your novel on it, and it was run over by a truck and then through a fire, you can send that garbage to drive savers, and they can often recover it. That's what they do mostly. They have things that have been found at the bottom of a lake, rusting in a broken car for years. Sometimes the data is really gone, but often you can get it back. And it's fun. We sometimes have tours there. They have like a surgery room. They have a clean room where you wear the bunny suits and the things covering your shoes, and you go through the suction thing to suck the dust off you. And in there, they have a giant wall of every kind of disk drive and SSD and everything. So whatever you have, they have another one, a brand new one that's exactly the same model. And they can take the components out of your damaged one and put them in a good one and sort of rebuild one, like Frankenstein, to make one that works. And they charge a lot of money, but they can really get your data back if anybody can. So for SSDs, is that due to the wear leveling? No, I don't think the wear leveling directly affects it, although that's another issue. That's why you might do this. Because of the wear leveling and because of the failure rate of SSDs, there are considerable memory segments on the SSD that have read errors that are silently replaced by others. So there is a lot of extra data on SSDs that you can't see anymore because it marks that sector bad and quit using it, but it does have some old data on it. That's why you might do this chip-off forensic if you really want to get it all. And by the way, that's true of most modern hard drives. Hard drives above 500 gigabytes, I've been told, have the same property where they silently replace bad clusters with other clusters, and so there is leftover data there that you can never read and never erase. And recovery does not, I'll tell you, if you go to Drive Savers, they tell you this: recovery will normally take like a week or two, but if you have an emergency and you pay them enough, they will do it fast. And they said you can call them on Christmas Day and say, I need it by tomorrow. And if you pay enough, they will do that. And I met the woman who runs their call center, and she used to run a suicide hotline. And they say people are very, very, very emotional. They say, oh my God, my computer crashed. My all-important thing is on it. My life is ruined. You call them and they will counsel you and calm you down and say, don't worry about it. Don't panic. Look, whatever you got, just put it in a box and mail it to us and we can get it back. Don't freak out. It's a they're a very happy company. They got people there that have stayed for 20 years working there because they pay for 6 weeks training every year for their people. They send you off to advanced training where you learn how to do all this black magic stuff. And so the people there are on the cutting edge of data recovery, and they really like their job, Yeah. So anyway, it's a fun place. And, there's at DEF CON, they have talks from these people. There's a whole bunch of people that really like to hack. Yeah, Nevada. Yeah, a whole bunch of people that really like to hack these hard drives and really get into messing around with the inside of storage units. I've been to some of their talks at DEF CON, and it's fun. Steve Gibson is probably the king of this. Steve Gibson runs a podcast, and he made the tool SpinRite that will fix broken hard drives by going really right down to the bits. And so he's one of the guys, that really gets into this stuff. And he writes it all directly in assembly code, too. He's really old school. But when he talks about it on his podcast, which is a fun one to listen to, that's Security Now, Steve Gibson's podcast. If you listen to that, he doesn't always talk about it, but sometimes he gets talking about his tool and hard drives, and he really knows a lot about everything that's going on hard drives and SSDs. It's a whole field. A drill into the disk drive? Oh yeah, just physically destroying disk drive is the way to really make sure it's done. Yeah, put it through a wood chipper. Put it through a log splitter, I've heard. I just drill them. Yeah. If you want to... Now with drill, in principle, you could recover the rest of it, but in practice, that means that nobody's going to get it unless they put a heroic effort into it. Yeah. They had a contest at DEF CON a few years ago where they took CDs and smashed them. And then you had to try to recover data from the smashed CD, and they were able to get 75% of it back. Yeah, that's right. Melting it in a furnace, breaking it into chunks. That's the way to really... Yeah, but if you totally melted it down or pulverized it, then you'd really feel good, like it's gone. Just drilling a hole through it is good enough for normal people, where it's not really, nuclear bomb secrets on there. Yep, destroying all these CDs, yep. Well, we may not have enough competitors today. I'll give it a few more seconds. At least we got more than 3. If you have only 3, the contest becomes degenerate. All right, we'll go with these. All right, so what's the hidden part of the disk? All right, that's the host protected area. Everybody got that? All right, which one lets you recover some deleted files? Yeah, that's a forensic image, of course. All right. All right, what kind of acquisition has the best chance of recovering deleted files? Yep. All right. Copying whole disk is, of course, the best thing. All right. What acquisition ensures that you only get files owned by the suspect? You must do a logical partition. Only the logical data is still in the file table and has an owner recorded. All the rest of the data, the ownership record is gone, and so you cannot be sure that it's owned by the suspect. All right, what kind of image is most likely to be accepted in court? Yeah, that's right. They're all the same. All these are mathematically identical. So one is just as good as another, unless you are unable to explain what you did in court. But technically, they're all the same. All right, what kind of image is easiest to use with open source tools? Okay, that's DD, direct image, which is apparently what you have of the Epic people now. All right, Jay's going to have to tell me a little more if they want their points. Keegan, that's a good name. I'm sure iGrader can tell who that is. And I know who that is. I think Jay might have used that name before, but anyway. All right. My grader might figure out who Jay is, but it's probably better to give me a little more information if you want your points. All right. So, good, we're on time. All right, so traditional duplication of a drive. You use what's called a static image, which means that the drive is collected in a powered off state. So nobody is writing to it anymore. Nothing is changing. Oh, thank you. Jay is Judy. Good. Good. That's more information. Good. All right. And so you now use a disk. You could use a hardware disk duplicator, or you could boot from a forensic live DVD, or you could use any of these forensic acquisition tools we've talked about. But you need a hardware write blocker. All the professionals use these. They cost a few $100. It's really pretty complicated, but it connects to the drive and it does not let anything be written to the drive. It connects to the computer through USB or other connector, and then the computer thinks it's updating like the journal and the recycle bin and the timestamp on here. It has memory in this, so it lies to the computer and says, oh yes, I've updated that stuff, but it doesn't pass those signals on to the drive. This is what multi-pros use because it's much more reliable than a software write blocker, which we're going to talk about. Software write blockers are what we often use in class because we don't have the money to buy hardware write blockers, but the pros use hardware write blockers. So Tableau or Wybatech are common companies that do this. They make them for all different drives and everything. But if you don't have a write blocker, you could use a boot disk. You could boot from a Linux forensic distribution, and there's a bunch of them. This is the current one that seems to be very popular, Sarugi. So you boot from this disk instead of from the hard drive, and then this special software on the disk boots a version of Linux that doesn't write anything to the drive. And then you can copy the drive, which is fine. The reason why this is for amateurs is because when you're trying to boot a computer from a disk, you have to do something like press F2 during boot up and select the boot device, and you could make a mistake. And if you make a mistake, it'll boot from the real hard drive, and then it's modifying the evidence. And that's why this is for amateurs. A pro would put a hardware write blocker on it, and then if you make some mistake with your software, it doesn't matter. The hardware write blocker protects the evidence. That's why, when you're seriously going, I've heard people say the right price to charge is $800 an hour for collecting data, and like $400 or $500 for analyzing it. So a few hundred to buy the right hardware is a small investment, and then you never have to go to court and go to your client and say, I made a mistake and altered the evidence. You don't want to be saying that. You just want to get a hardware write blocker and not alter the evidence. What are you, nuts? Anyway, so you can use DD or this digital forensic GC3DD or FTK Imager or Encase. You can also get hardware disk duplicators. People often do this not for forensic purposes, but just so they can deploy, 100 laptops all the same, 100 desktops all the same. They get a disk with all the software installed and just duplicate many copies of that disk. All right, so make sure your media is write protected. Make sure that you can, if you're trying to use one of those boot DVDs, then make sure that this process is automated so it's not going to accidentally alter the data. Make sure you have enough room to store the evidence you're collecting. If you're using command line tools, which is also not much recommended, make sure you know exactly what you're doing, because another common mistake is people make a mistake when using DD. You have to refer to the input file and the output files like dev/SDA and dev/SDB, and if you get them backwards, you copy your blank drive onto the evidence drive, which is another reason why you really should have a hardware write blocker. So that if you do that, it won't destroy the evidence. Anyway, yeah, you've done that. It's easy to copy to the wrong drive. Yeah, I've lost cloud servers that way. It's a common mistake. That's why, Linux people think they're so smart with these command line tools, and all the pros pay for expensive Windows tools and real hardware write blockers, and then in practice, you will not accidentally destroy the evidence so often. Anyway, so DD is the duplicator that comes with all Linux, but it doesn't create a hash value or anything. So the Department of Defense Computer Forensic Lab made a version of DD, GCFLDD, and GC3DD, which just add a few of the missing features to DD. They just create a hash value and record more information next to it. Just a little bit more professional than DD, although, it doesn't really matter that much. All right, but the problem is, ever since around Vista, I discovered this the hard way, every disk, if you boot a drive, every drive that computer sees, it connects to it and writes on it. It writes on every drive, even a drive you're not using. I had a multi-drive machine used in a classroom, and I installed an operating system on like partition E and booted to it, and some other teacher was using the one on partition C, and it ruined their stuff, which I did not think would happen. I thought they were independent. But when you boot drive E, it touches drive C and changes things. It records the time it booted up. It changes a journal, which records what's happening. It changes dates. And if the journal is an old version, it updates the journal to the new version, which is what hurt me. Because updating to like the Vista journal version, it could no longer boot Windows Server 2000 or Server 2003. So when I installed an operating system on a partition I was using, the other teacher could no longer boot their old OS on the other side, and I had no idea that would happen because of this. So that's the thing. That's why you need hardware write blockers. Even when you're not touching that drive, the operating system is touching it during boot up and changing things. Forensic Live DVDs have turned this off. So Forensic Live DVD will connect to drives without writing to them because they modified the software, like Sarugi. All right, so Encase is the one police departments typically use, and they give you a bunch of them. You can use Encase Forensics, there's command line versions, there's a Linux-based version. They give you all the tools you need as part of the Encase suite. And so you can also do live duplication, of course, which is what we mostly do in instant response, live imaging of a machine that's turned on and booted up, and therefore it's not going to be perfect at all. You're adding software, changing the contents of RAM, timestamps are changing. If you do it twice, you don't get exactly the same data, so it's a sloppier, less perfect procedure, but it's normally what you want in live imaging. So technically it's a smear. If you start copying the drive, then the part you start with you collect at one time, and the later part you collect it at a different time. And things are changing as you go along, so you don't even have a snapshot of the whole drive at one time. You've got a smear. That's why it's very far from that perfect static image. But it does tell you what's going on in the machine. And so this might be what you have to do for things you can't turn off, and of course for encrypted drives. If the drive is encrypted with something like BitLocker, then you pretty much have to boot it up and log in to get access to the drive. So live image is pretty much all you can do. Anyway, as always, document what you did and why you did it, because some question will come up later why I'm not seeing a standard complete forensic image here, and you want to have an answer for that. Even if the answer is, I didn't know how to make it, and this is the only thing I knew how to do. The truth is always the best answer, even if the truth is, I'm an idiot and there was a better way to do it, and I didn't do the right thing. Admitting that is a whole lot better than trying to cover it up. Anyway, all right, so live imaging, of course you have no write blocker, you are changing the system. In principle, you might destroy evidence, you might even crash the system. Sometimes people put the image on the evidence system, which means you're just overwriting more files. The best thing to do is run from a network share or a USB drive or a CD drive, and then copy the data onto a USB drive or a network share, so you don't change it any more than you have to. All right, Apple has another problem, of course. If you have like a MacBook Air or an iPhone for that matter, it's not very easy to take it apart and get to the storage device. Funny tools, funny connectors, and all that jazz. You can boot them up into target disk mode, so a Mac acts like a portable disk drive, and then you can image it over FireWire or Thunderbolt that way, and that's a pretty good solution. But you have to, anyway, you really have to know the hardware you're imaging. And of course, if you have these complicated things like RAIDs and SANs and NASs, then they're huge and complicated, and copying the whole thing is kind of insane, and if you did that, you would have a ton of data and have great struggling getting through it. So normally, it's hard to believe you actually want to copy the whole thing anyway. What's much more likely is some kind of logical image where you get copy some small amount of the data off that thing, what you need, with a live acquisition, is much more likely to get you to where you want to go. And then live imaging would be nice, and whatever you get, you can then put it in a folder and put a hash value on it, so at least you can make more copies of it later. But it would be a heroic project to actually make a complete bit copy of that kind of array and then reconstruct it. That's what DriveSaver does, and they charge enough money for it. All right, virtual machines, by the way, are incredibly easy to make images of because the whole hard drive is just stored in a file. So a virtual machine that's running is just a series of files in a folder. The hard drive is just a bunch of VMDK files, and the memory is a vmem file. So if you just copy all these files, you've got a perfect forensic image of it. That's it. That's why virtual machines are really pretty nice. And you can suspend it, and then it's off, but everything's there, including the memory, and you've got it, And a lot of what we're actually using now are cloud services, and almost all those things really are virtual machines. So it is pretty nice, except you normally don't have the access to get this kind of copy. Like you can't go to like Google Cloud Services and have this. Although I've been told you can make a backup of a Google Cloud machine, but it's not a forensic backup. You're only getting live files. I think I've heard of some people doing stuff like taking their Amazon Cloud machine and connecting it to a virtual CD and then putting something like Sarugi in there and then imaging it. There are ways, I think, to make forensic images of cloud machines, but you can't usually get at this level. The only person that can get at this level is the actual cloud service themselves. So the way to get that would be to like have a court order or something, or pay a fee for them to do it if they offer that service. But I don't know how many of them actually do offer that service. So normally you settle for logical acquisition of the live data out of cloud services. One thing that's nice, though, is Dropbox actually keeps backups of all the files old version 30 days back. So that's almost as good as getting the whole disk partition. That's a handy thing about Dropbox. And all you need for that is the usual kind of court order. Well, I thought there was at least one more person. Good. I'll give it a few more seconds. Oh, good. Wait, same person. All right. All right, I think we got everybody. All right, what's the software included in everybody's Linux? That's DD, used to copy any input to any output, used for a lot of purposes. All right. All right, which one is free Windows software? That's FTK Imager. Good. All right. Which one lets you collect a valid forensic image by just copying a few files? That's virtual machines. All right. All right, and which one is for Macs? That's target disk mode. Lets you treat your Mac as a USB hard drive or a FireWire hard drive, and then you can just copy the data off it. All right. I know who that is. And that also good. All good. All right. All right. I'll stop that video.